Two. All right, we're recording. Today's lesson is on histograms. So let's start by just reading what we have at the top up here. A middle school class studied the times that students woke up in the morning. They found that 2 students woke up almost an hour earlier than the others. The class wondered how much time it took each student to travel to school in the morning. The table below shows the data they collected. Based on the data, what 3 questions do you think the class asked? How might the class have collected the data, and what information would a line plot of the data give you, and then a bar graph? So let's just look at this really quick. And this is evidently a very large, a much larger school. They've got a lot of students that they... So let's look at this. They've got student, travel time, distance, mode of travel. So what 3 questions, did you have a question?
Yeah, can I answer the first?
Yes, so you can answer the first question, which is what 3 questions do you think the class asked? So what do you think?
I'm thinking basically, what time did you wake up?
Okay.
How many miles did you walk? And
so you're...
sorry.
That's okay. You have the right idea. I like it. Yeah. So when did you wake up might have been a good one.
How did you get to school?
How did you get to school? TJ, did you have any thoughts?
Okay, so it's asking the student initials and then how long it takes for you to get there, and then your distance, and then how you get to school.
Okay, so you're thinking it's really 4 questions because they do have their initials there, and maybe that was just so they kept track to make sure. So yeah, so that may have been a question they asked too. And then, so how long did it take you to get to school? How far is it from school? How did you get to school? And then they probably initialed just to make sure they weren't counting the same student twice. We do that, like this morning, you guys wrote your names on your papers. That's to make sure everybody got to vote. And we'll have to make sure Rabbit gets one of those, just thinking about that. All right, so that's good. It says, how might the class have collected the data? So what do you think? How do you think they got this information from students?
They stopped people.
Okay, raise your hand and then, okay, so what do you think, Rhett?
They stopped people.
Okay, they could have just went and did like an informal survey with a clipboard and wrote things down. What do you think, Shay?
They put a desk in front of the school, and then when the kids showed up...
Okay, they could have had somebody sitting outside the school and asking questions. What's another way they could have come up with this information? We're going to be doing our own surveys as part of our end-of-quarter project that'll probably bleed a little bit into the second quarter. Silas, what do you think?
They might have had like a check-in station where they write their names and their...
Okay, check-in station, kind of what she was saying. What do you think, TJ?
Maybe the people that got this went to all of those kids.
Went to all of those kids. So did I go to all of you and just talk to you individually this morning when we did our survey? Rhett. What did we do? What did we do this morning?
Maybe they handed out paper.
Okay, what was your answer to the other question?
They made themselves friends with the people, and then they stalked them slowly.
Okay, I don't think they stalked them slowly. Shay, what do you think?
They handed out a piece of paper and they had...
Handed out a piece of paper. What do we call that? We hand out a piece of paper and people answer it. Sometimes your parents get these in the mail, or we do one online. What do you think?
A survey.
A survey. So a survey, what would be the advantages of doing a survey rather than stopping people at the door, do you think?
That you get all of the information with a lot less work.
All the information with a lot less work. Nobody has to set up a desk outside. You don't have to talk to every last person. Just hand them a piece of paper, have them fill it out, turn it back in. Here at school, we use SurveyMonkey a lot. If we have to do a survey, and I had you guys do a survey through the Cahoots website last year where you do it online, and a lot of surveys are done that way. So we're going to have to think about when we do our survey, whether we want to do a paper survey, whether we want to try to do an electronic survey. We're going to have some different choices. All right, so it says, what information would a line plot of the data give you is the first question. So they've made one for us, which I think is nice. Down here below, they've made this line plot. Dot plot is the other word that we've used for this a lot. What information do you think this is giving us? If we're looking at this and you're taking a quick glance, what sort of conclusions can you come to, TJ?
Time traveled in minutes.
Okay, so it's giving us the time traveled in minutes. So 1 hour is 60 minutes instead of 1 hour, so that's good. And then if I'm looking at where the dots are, what is this going to tell us about the majority of the students? Think about it for a second. What do you think?
And a majority of them take less time to get to school.
Okay, so majority of them are on this end, between like 5 and 25 minutes. Like you could say that this is a cluster right here, in here. Somebody's alarm's going off. All right, so most people, it looks like, take less than half an hour. There's only a handful of people taking more than a half an hour to get to school in the morning. And I would say that's pretty typical. Most people live pretty close to where they go to school, but there are people who travel quite a bit. Where I used to work in Kansas, we had kids that drove as far, in high school, as far as an hour and 15 minutes every morning to come to school, because it was out in a rural area and they lived on a farm or a ranch in the middle of nowhere, and so they did have a long commute time. The bus didn't go that far, so they had to, a parent or themselves, they had to drive quite a ways, and so sometimes that does happen. Okay, so if you lived in Powderhorn and you were choosing to come to here or Gunnison, that's a pretty decent travel time too. All right, so we're going to move on. Before we do anything else, let's talk about this distribution really quick. Who can tell me what the shape of this is? Shay.
Skewed right.
Okay, so I'm going to write that down just because I want to review this information since we have a test coming up next week. It is skewed right, meaning most of the data is on the left. It sort of trails off on the right. We've got a couple of outliers over here where it sort of like strings it out, and that's why it's called skewed right, because the right side is where it starts to break apart. Okay? And then we already talked about clusters a little bit. We sort of have some clusters over here on the right-hand side, some big gaps over here. All of that we could talk about. Why do you think, or do you think, is this a really good representation of the data? If I had you tell me what all of these numbers are, how easy would it be for you to tell me what some of these dots are where they're really grouped together? You thinking not so easy? Okay, so look at the number line here. Most of our dot plots we've done by ones, but this one had such a huge range. They've numbered by fives. When you do a dot plot, we don't group them. They actually will put the numbers in between and kind of estimate where they go. It's a little tricky to try to figure out what exactly all the numbers are, and some of them just get all like messed up here. And that's why we're going to go and use a grouped bar chart today, the histograms, is to show you another way that we can represent the data. Okay, so the data on student travel times vary from 5 minutes to 55 minutes is what it's telling us. Although we have a 60, so I think that's a typo. This just came out of the book, so I'm going to put a 60 there. So it varies from 5 minutes to 60 minutes. So we could come up with a range really quick for that. So how do we find range? Rhett. C. What do you think?
You subtract 5 from 60 and you get
Okay, so 60 minus 5 and we get 55. So there's a range of 55 minutes. That's a pretty good range. It wouldn't be quite as big if we took out these two kids that travel a long way though. If we took out those outliers, it'd be a little shorter. Okay, so you want your notebooks open where you can see this page with all of your times to do the next part. I'm going to talk you through what the next page is asking for, and then we're going to go back and forth between the two pages. So you're going to have to stay with me. I know this is maybe not the most sterling thing you did today, but it's kind of interesting how this is going to come together. So number 1 says we're going to make a histogram with an interval size of 10. For the sake of time, I set this up for you, but you need to know what this means because you will have to set some up on yourselves. This down here where it goes 10, 20, 30, 40, 50, 60, 70, that's giving us our intervals. Sometimes we call that the scale. It's kind of the same thing. It's how you're counting down here along the x-axis. Up here along the y-axis, you just do whatever you have to do to make it fit. But they want this to go by tens. And the reason it's important that you pay attention to that is you may group things differently. You have to group these into bars evenly. So everything before 10 would go in this first bar. So everything from 0 minutes up to 9 minutes would be the first bar. 10 to 19, 20 to 29, all the way across. And there's a couple of ways we could do this, but I really feel like making a frequency table is going to be the way to go to start. So let's just go back to, and it doesn't tell us what we're making a bar graph for, and that's my fault. So we're going to do travel time. So that should have been in the directions. Since you have all of these different numbers, we're going to do travel time for both of these. And I'm sorry I didn't get that typed in. I was trying to condense this down and I rewrote some things. Okay? Yes. Really quick because you're going to miss instruction. All right, so over here, it might help some of you to take a highlighter if we're doing travel times and highlight the travel times. You know what I just realized is they put the travel times in order for us, so this may not be so bad.
Yay!
They're not always going to be in order, but we can kind of work with this. So what we need to do is think about what our groups are. So off to the side, I'm going to make a little list. So I'm going to have the times and then the frequency. I'm just going to put freak, F-R-E-Q. And so we need to figure out everything from 0 to 9 minutes, 10 to 19, 20 to 29, 30 to 39, and just keep going until we hit that 60. 40 to 49, 50 to 59, and then 60 to 69. And then we're going to figure out how many are in each one of these. So it's a blessing that the book put these in order, because if they didn't, you'd have to go through and it would be a little bit harder to find these. I just now realized it. So how many numbers would we have that are in the 0 to 9 minute bar? So that would be everything from this 5 down to this 8. How many people is that? 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. When we hit 10, that's going to be in the next bar. So I'm just going to put 6 over here. And we'll put it on the graph here in a second. And then our next one is from 10 to 19. So that's going to be quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're only going up to 19. So there were 17 students that had from 10 to 19 minutes. Okay? And then 20 to 29, we just start with 20. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll put 10. 30 to 39, I've just got 1, 2, 3, 4, 5. 40 to 49, we don't have anything. It just skips to 50. So this 50, there's one that goes in the 50s, and then there's one that goes in the 60s. So this is how I think about it. When you do an interval of 10, I always think, okay, single digits, teens, 20s, 30s, 40s, 50s, 60s. Like that's just how I think of it, because that helps me keep that straight to make my bars. So we just basically counted these and made ourselves a little list. That way we can go over to the bar chart and make the bars. And making the bar chart is just like making bar charts. We're in elementary. We're just going to make the bars this high. So let me see if I can put both of those on the screen at the same time. So here's our times and our frequencies. So in this bar that's below 10, that's your 0 to 9 minutes, we need our bar to go up to 6. So we're just going to make a bar. If you want to color it in, okay. If you just want to do an outline, that's okay too. Don't spend a lot of time coloring, because the main idea is here is just to neatly make a bar that you can tell how high it is. Okay? And then from 10 to 19, it needs to go all the way up to 17, which is up here. So that's this bar, and maybe I'll shade that one like this. When I was in school, we didn't really have colored pencils or markers or highlighters in math class. We just shaded everything differently. So
What does it go up to?
it goes up to 17, so it's on your list. It's all of the teens. All of the times that were in the teens go between the 10 and 20 down here. And then 20 to 29 says it goes up to 10. So I'm just going back to this chart that we just made. I'm just making the heights of the bars. So maybe this one I'll shade this way really quick. And then 30 to 39, we only had 5 kids that were in the 30-minute bar. And so maybe I'll shade those vertically like this. And then we will not have a bar between 40 and 50. There's nothing with 40s. There's only 1 student in the 50s, so we're going to have one little short bar over here. We'll shade it horizontally like that. And then there's 1 person that had 60. So that goes in the 60 to 70 bar this way. So I'll try to shade that one a little differently. So that's what it's going to look like. So you have a bar for each category. So the idea, the difference between this and a regular bar graph is that each bar has a group of numbers. It's not just like the kids who had 5 minutes and the kids who had 6 minutes and the kids who had 7 minutes. We're grouping everything under 10 in here. And then all of the teens here, the 20s here, the 30s here, 50s and 60s. Does that make sense? Now, how you group it may depend. You can group it different ways. So what it's going to ask us to do next is we're going to make a histogram with an interval size of 5. So I've numbered it down here, 5, 10, 15, 20. So this is my interval size, which we sometimes call the scale when we're doing other graphs. It's the same idea. We're counting by 5s. So it's going to be a little different to group them for this, because now it's like everything under 5, and then from 5 up to 9, and then so we're going to have a slightly different list. So let's go back to our numbers. So our first bar is everything less than 5. Did we have any students over here that had less than 5 minutes? No. We had some with 5. Now 5 goes with the bar to the right of 5. So everything from 5 to 10, everything in this bar is going to be from 5 up to 9, and then 10 goes with the next one. So everything from 5 to 9 is what we need to look for. So we've got 1, 2, 3, 4, 5, 6 kids that were from 5 up to 9. Does that make sense? So 1, 2, 3, 4, 5, 6. So
the same thing, except just a little bit different because
it's going to look a little differently because they're grouped into groups of 5 instead of groups of 10. So this bar is going to look it'll look different. Just hang on to see. So this bar represents everyone from 5 to 9 minutes. 10 goes to the next bar. So if it lands right on one of these numbers, it goes to the right. And that's a little tricky to remember. They used to do things where they would just say, oh, this is 5 to 9, and they'd put it under the bar. But because of the technology you guys are required to learn in high school on the graphing calculators, this is how it sets it up. So they're trying to prepare you for that. It has to do with the modern tech that we use and how it's numbered. So, all right, so the next bar would be everything from 10 to 14, because 15 would go with the next bar. So how many do we have from 10 to 14? So 1, 2, 3, 4, 5, and then we hit 15, which goes in the next bar. So we're going to make this bar go up to 5. We'll shade that in. And just to clarify, this bar is everything from 10 to 14. Normally, you're not going to write these at the top, but I'm trying to make sure it's super clear. I think the 10s are easier because you can just think it as teens, 20s, 30s, 40s. You start breaking it up into other groups, it gets a little bit more interesting. Okay, so then when we get to 15, there's quite a few. The next bar is everything from 15 to 19. So let's go over and count those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my next bar is going to be 12. I got to erase what I wrote so it doesn't run into my bar. So we'll go up to 12, and I'll just shade that one this way. So this was 10 to 14. This is 15 to 19. So everything from the number on the left to just under the number on the right. And then the next bar starts with 20 and goes to 24. So we go back. We've got 1, 2, 3, 4, 5, 6, 7, 8 before we hit 25. So there's going to be 8 in the 20 to 25 box. So make the 8. I'm going to shade that one vertically. You could use different colors, but I didn't want to drag everything out right now. So this is everything from 20 to 24. And then our next category is 25 to 29. So there's just 2 25s. If I look back over here, there's just 25 and 25. There's 2 of those. So we'll just make a bar that's too high. I'm just going to leave that one not filled in because I feel like it. And then the next bar starts with 30 and goes to 34. So we have 1, 2, 3 30s. So if we go over, we're going to have a bar that goes up to 3. And then I'm running out of ways to shade. I'll do this one horizontal. And then the next bar starts at 35. So if we get back over, there's 2 that are 35. So that'll be 2 like this. And I'm going to cross hatch that one. So do vertical and horizontal on that bar. And then we just had our 50 and our 60. So where would I put, so this kid, initials AB, had 50 minutes. Where does his bar go? Raise your hand if you can tell me where that's going to go, TJ. Between 50 and 55. So this one kid, if it's right at 50, this bar represents 50 to 54. It starts with 50. And so that's where that kid's going to go. And then we had another kid with 60. So there's nothing from 55 to 60. The kid that had 60 goes with this bar because this bar is 60 to 64. And hopefully, and I'm going to cross hatch that one this way just to shade it differently. So Jaden surmised earlier that these are going to look pretty similar, and they are. And they have the same shape that our dot plot did. They are skewed right. This gives us a little bit more detailed information. What do you think?
Yeah, they're like the same graphs, but one's just like a little bit more detailed.
This one's more detailed, and what happens is the bars are not going to be as high because they're getting split up into smaller groups. And a lot of times we don't want to deal with 1, 2, 3, 4, 5, 6, 7, 8, 9 bars. And so that's why you might want to do this. A lot of times we want to keep it like under 6 bars just to keep it manageable, to make it a little easier to read. Because I don't know if 5-minute intervals would be that important for whatever they're trying to study here. All right, so down here they're going to ask a question. I've actually answered this question already, and we talked about it with the definition, but we'll see if you guys are paying attention. How is a histogram like a bar graph? So raise your hand. Think about it first, though. How is it like a bar graph? Silas?
It has bars.
It has bars.
An X and Y axis.
Okay, so it has bars. It has the X and Y axis. How is it different? I'll let you guys write, and then we'll do the next question. I'm rushing. And I just realized that we should have labeled some things on our graphs too, so we'll go back and do that here in a second on the X and Y axis. Okay, so it has bars, it has an X and Y axis, so that's how it's like a bar graph. We answered this question, but it also asks, how is it different? How is this different from a regular bar graph that you would have done in elementary? Go ahead.
It groups them.
Okay, so it's different because the data is grouped. We don't have individual bars for individual numbers. Can you imagine making a bar graph? Okay, here's all the 5s, here's the 6s, here's the 7s, here's the 8s. It goes everywhere from 5 to 60. You could have potentially 55 bars. That would take forever, and it would be really awful to read.
Mamma mia.
So that's why we group things like this. And you will see this a lot in real life, because in real life there's often a lot of spread, and that's just how they do it. So I messed up. We're going to go back and label some things. So we need to label our axes, what they're representing. So down here, this was our travel times. And we should label, how are we measuring time? Days? Months? Minutes. So we're just going to put a little MIN underneath that. That's important. And then what are we counting up this way? It's the frequency, but if there's 6 in this bar, what does that 6 represent? Jaden. Okay. TJ.
The amount of people that have.
Okay, so these are students. So we're going to just put number of students on this side. And then we can do the same thing on the other graph. It's still representing travel times. Sorry, my mic's really too close to my mouth. It's echoing. So travel time in minutes we should have there. And this is the number of students that are in each group. That's really what we're measuring with the height of each bar, is how many students were in each of these little groups that we made. So it's really important to make labels. And I sort of made titles a little bit ago when I wrote travel time up there. In the book, they also do some histograms for the distance, and we're condensing a little bit since the quarter's almost over. I want you guys to at least have an idea what this looks like. So just compare the two histograms. How does each help you to describe student travel times? This is an open-ended question that really doesn't have like a set answer. Some of you are really struggling when the book does these and we have to grade them. Sometimes there's not like technically a right or wrong answer. There can be a wrong answer if you don't actually answer the question that's asked, but this is where you get to give some opinion. Okay, so if it says, how does each help you to describe, what is the, so what would be the pros and cons of each? What would be the pros of the first one? TJ.
It has less bars.
Okay, so the first histogram, I would say, is easier to read. It's easier to read because it has fewer bars. It's asking us, how does each help us? So, and we're also getting that comparison in there. So the second histogram, what would be the pros of the second histogram? We've already answered that question, but we're going to write it down. Why would we want it spread out more like that? Go ahead.
It's more detailed.
Okay, it has more details. Has more, I'm going to put more detailed info. Okay, so this one is more detailed. You can see more of the differences. There were a lot of kids on the first one in the teens, and here you can see how many were less than 15 minutes and more than 15 minutes. So it's broken down a little bit more. So we've compared them a little bit, and we've talked about how each helps us. Like we're sort of showing how they're different a little bit, but we're also describing how each one would help us to describe. We're doing great on time. We got 5 minutes. So which students would have to wake up the earliest in the morning? I want you to think about this. You've answered quite a few. Somebody hasn't answered a whole lot. You've answered some. Johnny, which kids are going to have to wake up the earliest in the morning?
The students with the most travel time.
The students with the most travel time. So which ones were those? They have their initials there. Go ahead, Johnny. If you're looking back on the table, it'd be over here at the end. A, B, and DB. We don't know their actual names, but AB had 50 minutes a travel time, and DB, if you have to be in your car, or on, I guess this was on the bus, so both of them are on the bus. If you had to be on the bus for an hour, you're going to have to get up earlier. Where I lived, it was really remote, but they did run buses. I rode the bus for over an hour morning and night to get to school and back. And when we had to meet the bus at 7 in the morning, sometimes 6:45. You had to be out there to be on the bus, so we had to get up super early. So school started at 8 o'clock.